Hi, thanks for joining. This is Miguel, and today we are gonna learn how to do classification on this iris dataset. So, I have prepared this Python notebook in order to show you. So, first, and this is the first step, is to define the libraries that we are gonna use in this. So, we will include the libraries that we are gonna include for plotting, for machine learning, etc. So after this, the first step is to do this data exploration. So first, we read the dataset, which is part of the scikit-learn library, and we can do a preliminary study of how it is. So for example, we can print the number of rows and the number of columns that we have. Second, we can organize this data into a pandas data frame. So what is a pandas data frame? It is something like this. These are just the 5 first rows. So what you can see is that it is kind of a table. So in this way it is much easier to see how the data is organized and see the different features that we have. So then in order to analyze it a little bit more, what we have done is to do this plot in which I have plot the force features that we have for each one of the 3 types. So that's why in each plot you see three lines. So with this we can see that some of the features have like more or less the same value for the 3 types, but in other features they are more spread away. So that's good actually. We can also plot this correlation matrix between the different features that we have. So in this case we can see that for the type, which is the target that we want to predict, the 2 most correlated features are petal length and petal width. Then we have sepal length and sepal width. We have a slightly lower correlation and negative in case of the sepal width. So then the next step is to do this splitting in training and testing set. So we have some samples, a number of samples, and we will take 30% of those samples and we'll use them for the testing set, so not for training the algorithm. Then we reach the next stage, which is the machine learning stage, the one that it is cool. So we are going to use this random forest classifier, which is a very powerful classifier just for this problem, but it's okay. So we are gonna use the default parameters, and we are just gonna set this max depth to 3, which is about the depth of the trees that we are gonna use, but it's not that important right now. So with this command we initialize the classifier, and with this command we train it. Once we have trained it, with this command we can do the predictions for the testing dataset. So just the last step is to analyze those results. So the first thing that we can do is to plot this confusion matrix. So here we can see the true positive, false positive, and false negatives for each class. So analyzing this, for example, we have that for the class 0 all the samples are correctly predicted because we only have numbers in the diagonal of this case. However, for class number 1 we have 16 samples, but one of these samples is classified as class number 2. Then for class number 2 the accuracy is also perfect, so it's fine. So then the accuracy is very easy to calculate. It is just to add the numbers in the diagonal and divide by the length of the test set. Finally, we can plot this in which we can see the feature importance for the classifier. So here we can see that the classifier considers as most important feature the petal length, followed by the petal width. Actually, this is very interesting because in the analysis that we did before, we saw that both petal length and petal width were the most correlated with the target. So that's all. Thank you for joining, and I hope you like it. See you.